we're going to talk about dilution. So this is 14.2 continuation. So we're going to call this part 2. All right. So dilutions. So in chemistry, we can't buy, especially in like high school chemistry labs, we can't buy everything in pure concentration. So like if I were to go buy hydrochloric acid, for example, I can't buy every single concentration that we need. It's just impractical. So what we do is we buy the most concentrated form that there is. So we buy what's considered the stock solution, and then we water it down. So we dilute it in order to make the molarity that we want. We get our desired concentration from it. And then that way we have whatever concentration that we want, and we can use in our labs, and we can keep what we want and get rid of what we want. And that way we're not having, you know, storage issues and that kind of thing. So dilution then is just the process of adding more solvent. So the key there word that we're looking at right here is solvent. The process of adding more solvent to a solution. So we're not adding more solute, we're adding solvent. So we're adding water or alcohol, some kind of solvent to our solution. And since we're adding solvent, not solute, the number of moles that we start our solution with and the number of moles that we end a solution with are exactly the same. So the moles we start with, the moles we end with are exactly the same. So that allows for us to do some really fancy math. And I'm not going to get into, I'm going to show it to you, but we're not going to really talk about it. Here's the fancy math that we're going to do. Basically what it allows for us to do is to set up two big M equals moles over liters equations. And since the moles are equal, we can solve for those, shove them together. And it allows for us to basically get this one final equation, which is most important to us. And this is the dilution equation. And the dilution equation is big M1 times V1 equals big M2 times V2. And so this allows for us to take any basic like stock solution, so its concentration, and if we wanted to, you know, multiply its volume, it should be equal to that new concentration times the new volume. And this is really helpful. I use this equation all the time when I'm trying to make, you know, solutions for your class. Like for example, I have, you know, a 12 molar hydrochloric acid solution. So I know the concentration of the stock solution. And so I put it there. And I want to figure, I know that I need to make you guys a 1 molar solution. And I only need, you know, 1 liter of it. Well, how much of that original hydrochloric acid do I need in order to dilute it down? Well, I figure out what V1 is. And that's actually what we're going to do in the example. The example shows or asks what volume of a 16 molar sulfuric acid must be used to prepare 1.5 liters of a 0.1 molar H2SO4 solution. So this is exactly what I'm talking about, where you have 16 molars sulfuric acid, so a concentrated bottle of acid, but obviously I'm not going to hand over a 16 molar bottle of acid. We don't need that for a lab. It's way too concentrated. So we're going to water it down. We're just going to take...
Mr. Frederick, please call 4007. Mr. Frederick, 4007. Thank you.
You can tell I'm taping this at school. You're going to take 1.5 liters of a 0.1 molar solution, and we're going to, you know, that's what we actually need. So that's what we're going to do here. All right, so what I'm going to do here is I'm going to use my M1 V1 equals M2 V2. That's my equation. Now, my original stock solution was 16 molar. And I like parentheses. It's up to you how you like your math. I like putting parentheses there. I have 16 molar. I need to figure out how much of that I'm going to dilute down. So my volume that I'm trying to find is unknown. So that's going to be my V1. And notice how they grouped it in the problem too. They gave you 16 molar with nothing, and then they gave you a bunch of other information together. So it's already grouped even. So your other side, M2, they gave you a separate 0.10 molar, and they gave you 1.5 liters. This equation is kind of cool too because it doesn't matter if you use liters or milliliters as long as you're consistent. Meaning that I could use milliliters for this equation as long as I make sure that I use the same thing on both. And so then whenever I solve for it, it would be the same. So if this 1.5 was milliliters and I solve for V1, it would be in milliliters. So right now my 1.5 is in liters, so I'm going to solve and it's going to be in liters. So that's the cool thing about this equation too, that as long as you're consistent, it works out. I love this equation. So I have, now I have 16V1 equals, and so I'm going to multiply those two numbers together, and so that's going to give me, let's see, 0.15, right? And then I'm going to divide each side by 16, and so V1 is equal to 0.009375. And this is another reason why a lot of times you work in terms of milliliters. So this is liters, because look at how small a number of liters we get. That is incredibly small. And then you go back up at the top, look at all your sig figs. Everything has 2, so you can have 2, so your volume equals 0.0094 liters. So most of the time, chemists, what they would do, you don't have to. I would accept either one. A lot of times what they would do is go ahead and put 9.4 milliliters, just because obviously to measure things out, that would make more sense. But either one of those would be absolutely acceptable answers. So that's the dilution equation. That's basically what you'll be doing for your homework.